So let's do it in English. Too bad. Okay, no problem. So let's go, we're going to start. So thank you for joining us for this return of experience session on data and FinOps and sustaining the cloud honeymoon without the cost hangover. So what are we going to talk about today? So short introduction about who we are, what is Veepee, of course, and then we're talking about the cloud. Is it really a honeymoon? Then we will explain you what we set up this FinOps methodology and we present you concrete use cases we faced in order to hopefully keep this honeymoon with the cloud, and of course with the conclusion. So first, before starting presenting the Veepee, the company, let's introduce ourselves. So I'm Pascal Cohen. Some of you already know me. I used to work in social police. I'm part of the staff of Riviera, and I'm really happy to do a talk today. And you can follow me on Twitter if you want. X, with Pascal Cohen. And I'm lead data engineer in Veepee, in charge of all the data science teams to have data ingestion and helping them at data science level to develop solutions. And today I'm doing the presentation with Victor, who is the head of data platform, who will introduce himself.
Hello. Yes, indeed. So working in Veepee for more than 5 years now, leading the data platform team. So it's a platform team dedicated to the data department. We have a very specific set of tools, a very specific stack in the department, in the data department. So we have a platform team dedicated to it. What I did in Veepee, so I have a very particular path in the company as I worked in many data positions, data science and engineering.
Sorry. So we take both mics. Okay. Sorry. Yeah, let's follow up with the company presentation. So first, who knows Veepee? Who bought on the website? Yeah, this year. Okay. So Veepee, it's the new name, not so new because it's been a couple of years now, almost 4 years since we changed. It's the new name of Vente Privée, venteprivée.com. It's the French company, Vente Privée, who bought a lot of similar companies in Europe and in South America, and who created this new brand, Veepee, that is now the main brand for all these websites that are selling, that are specialized in the flash sales business. So flash sales business, what do we do? What do we sell? Veepee is offering product for a defined period of time and with very hard discount. Okay, so our job, not as data specialists, but as Veepee, is to discuss with the brands, with fashion brands, but not only. You see also other type of product, non-fashion. We also sell trips and a lot of wine, for instance, a lot of different things, events, media. But the concept is always the same. There is a sale that is open for 3 to 7 days maximum. And we have a very interesting offer in terms of discount with the product inside the sale. Okay. So we are the market leader on this specific flash sales market, covering around 10 to 12, depending if we count the South American market, 10 to 12 countries. And it's a group, Veepee, that is doing and generating more than 3 billion euros a year in terms of turnover, around 5,000 employees. So it's a big company, but it's also a big tech company. It's a digital native, as we say. So Veepee, it was created more than 25 years ago, at least the website part of Veepee. So we have around 700 people working in the tech department. And for the data department, because we are part of the data department, it's around 50 specialists. So this department is split into 5 perimeters. I will not go, it's not the purpose of the talk to go in details on how we are structured. With Pascal, we are working in the platform and the science perimeters as the lead data engineer for Pascal and as the lead of the team for platform on my side. So you see, we have on the right teams perimeters that are really dedicated to finding value in the data, discussing a lot with the business, defining use cases. And on the left, we have teams that are more on transversal topics and provided services for the teams that find the value in the data. So the platform, for instance, because we will discuss about FinOps and infrastructure. So the platform is providing services and expertise on cloud services, for instance, for the rest of the teams. Some key numbers, maybe to understand a bit better what we deal with on a daily basis. So first, the first number, do you have any idea about what it can represent? Sorry? It's the number of messages we ingest a day. Okay, so number of rows in a table. The second one, well, obviously, is the size of the logical bytes that we store. And the last one is the number the number of product teams that are pushing entities through a centralized ingestion platform. We have more than, because this is very specific, but we have more than 80 product teams in Veepee, pushing some data entities, exposing some data entities for the rest of the group for reporting purpose, for instance. Take this one.
Yeah, we'll take the mic. So now it's time to talk about the honeymoon. So as Victor said, we started from this a few years ago. So 3 different stacks: vente exclusive in Belgium, Netherlands, vente privée, and Privalia in Spain. And you can see that it was very heterogeneous, with cloud solutions, on-premises solutions, with Spark, with JCP, with AWS. So we really have to shape from scratch to mix all these solutions into a brand new solution. It was a great opportunity to create something really new using a new stack and to maybe learn from past experiences. And this is what we did. And we just ingested all the, I would say, the best from all solutions. And we started on the JCP stack with various Veepee tech data coming from all parts of the organization. It was the data sources. Then we have part of data ingestion. It's really common sense. What we set up was, in my opinion, not rocket science, but the good habits. And all this is stored in BigQuery. And then we have data transformation with a tool that we use instead of Spark or other tools for the transformation, which is DBT. So maybe some of you use it. We use intensively this solution to do the transformation. So we use BigQuery as a storage, and then we expose the data to various customers internally, analytics people, create dashboarding. We have also a reporting solution with MicroStrategy for business analysts as well. And then data scientists do a lot of work with this data to do machine learning, to do science in order to develop the solutions that Victor presented. For example, for the personalization, when you connect to Veepee, you get customized solution using data science to propose you the best service, the best product that you might be interested in. So if you like, for example, sports, we will propose you sportswear, tennis, rackets, or whatever. And if you prefer food, you will probably get proposals based on pasta or whatever else.
Just Pascal, there are 2 names, product names that we will use a lot, I think, in the presentation. They are BigQuery and Dataflow, and maybe not all of you are familiar with the GCP services for data. So BigQuery, it's the cloud warehouse that we use. Okay, so it's a place where we run all the query and where we store all the analytics, the data that we want for analytics purposes. And Dataflow, you will see it later, it's a runner that we use to run streaming or batch pipelines. Okay, so it's a tool to provision machine and to handle scaling for us.
So we were able to set up all this solution, merging the different companies into a common solution. And it was the beginning of the honeymoon, because we were able to develop very quickly solutions that created added value for the company. We were able to create what we call personalization. So when you connect to the web page, you can get recommendation based on your preferences, but also forecasting products for internal logistics. You can have prediction about the best price to set, the volume that is predicted to be sold, to optimize the storage into the logistics. So it was really a nice start. And I think people were very happy about the capability to provide very quickly great solution and increase the value of what we sell. But was it the end of the honeymoon? Because as I said this morning, the cloud is a very costly partner. It can become a costly partner because you do things and the price can increase very, very quickly. And at the beginning, when we sold this proposal on the cloud, we got the trust from the management about the cost control, the capability to create really added value while keeping cost under control. And step by step, by developing new solutions, by consuming more and more data, by creating new features, we were a bit getting out of the trust, out of the contract. And this is where we started to have a look at FinOps. And Victor will explain what we implemented, what is the FinOps methodology, so that we can gain the trust again with our management.
Okay, so in the department, we have an approach for FinOps that is really, it's our approach in the data department. It's not something that we share a lot with Veepee because something specific with Veepee is that Veepee Tech is doing a lot of things on-prem and is building cloud solutions, private cloud solutions. So we are a bit isolated regarding this usage and this kind of tools in Veepee. So we built in the department an approach and we try to define something inside the department. So financial operation, FinOps, that's the main topic today. Of course, it's the idea of taking into account the cost from the beginning. Okay, when you start a project, when you build something, when you make an evolution, you want to take into account the resource usage, the cost and the resource efficiency are, of course, tightly related. Okay, and the main principles that we use are also quite obvious. Collaboration. It's all about finding tips and finding what other teams did to optimize things. So it's really about, okay, do we share the things? Do we have the ceremonies? Do we have so the meetings, the places to share about these topics? Do we have the documentation somewhere? Do we have the habits to understand what has been done in the past and to not reproduce the mistakes in the future? Data-driven decision, of course, and we are in a data department, so taking informed decision is the value, is the added value of our department for the company. So we need to apply this concept to this principle to our own department. So the idea is, okay, do we have the data? Do we have it often, real time maybe? And can we have informed decision? Can we take informed decision? Can we have alerts? These kind of things. Accountability, another very, very important principle, is that we need to make sure that costs and teams are not shared. Okay, the costs are not shared between perimeters, teams, and product. We need to make sure that people, or at least teams, are accountable for what they do. Okay, it's very important if you want to have people involved in this topic. Okay. We try to apply a framework that Google is GCP, Google Cloud is pushing. It's a very simple framework in 3 steps: inform, optimize, operate. Inform. Do I have access to the data? At which frequency? How do I group? It's very similar to what I just explained, all about the data. Inform. Optimize. So I have the data. Can I take cost-effective actions right now? And at which effort? Of course, I want to have the most, the biggest impact with the lowest effort. Okay, at least at first. And operate. I have new project, new things to come. I want to include these habits of FinOps in the way teams are building their product. Okay, I need to anticipate and to think about my architecture based also on the resource optimization and the resource usage, cloud resource. Okay, so let's try to give more details about these 3 different steps. Inform. As I said, let's be data-driven. So the idea of the call is also to, the talk, sorry, is also to give you tips and things that you can apply right now in your own companies. The first step when you start with FinOps topic is really to look at what you already have. And do you have the data? And do you have to set up things in the different tools, in the cloud tools, to have access to the data? So export and store all billing data, of course, but also all metrics that you could have from monitoring services in the cloud services to work on the allocation or to work on the split of the resource usage. Okay, of course, the billing data are behind. There is a unit and there is a time window. Okay, you pay for an amount of RAM for a specific time. Okay, so if you have access to metrics, you will be able to have access to the cost behind. So try to export as many things as you can. Allocate cost. Whenever you have all the data, you need to work on your perimeter assessment, on how the teams are defined, and do I have one product inside only one team, inside only one perimeter, or do I have teams that share the responsibility, the accountability for one product? If it is the case, you need to decide who will be responsible of the cost or the resource of this product. And that's a very, very important aspect. Allocate the cost. Work on your perimeters, team, product. Monitor on different frequency with boards and alerts. So it's all about the tooling. Do I have access to default dashboards from my cloud provider, or do I need to build something on my side? Anyone now can run a Metabase, a BI tool, and have a few charts running. The data here is not big, okay? It's just a billing data. So it's very easy to build something with daily data, not real-time data, with daily data, weekly data, monthly data. But you need to build the tools or to look for the ones that are provided by the cloud provider. Yeah, so that's exactly what I wrote. Sorry, on below. On our side, what do? We use MicroStrategy board. So MicroStrategy is the BI tool that we use in Vente Privée, in Veepee. And we also use default GCP billing boards. And we have, and I'm coming back to maybe you can go to the next slide. We had this issue of the accountability because I will take this example to try to emphasize what to have an example of what I try to explain. Is the fact that sometimes you have costs that are under only one perimeter, and it's like this. You cannot split them by default. Okay, so if you have a kube cluster, for instance, and you are the team that provides this service for the other teams, you will not have costs in your cloud provider exports per different perimeter. Okay, the cluster is running in one Google project or in one specific cluster, so it's by default in one team. So you need to reallocate the cost, and for that, you can do very simple things. Export the metrics. Maybe you can export the metrics, the usage metrics, and try to decide, okay, we will allocate the global price per compute usage or per memory usage. And that's, for instance, what we could do on our side for a monthly 10,000 euros. You are the only one providing value with this. So. Yeah, so we extract the billing data, we extract the metrics from the Cube services, Google Kubernetes Engine, for instance, and then we join the data and we try to allocate this for on a monthly basis. Optimize, easy wins. So that's the second step. Okay, whenever I have the data, now I need to take actions, because if I don't, if I identify that we have leaks or that we have huge costs or inefficiencies, I can take actions right now. I don't need to wait. So you can cut a lot of, when you do the exercise for the first time, you can cut a lot of useless resource. For instance, you will maybe see that you are spending 15,000 euros a month in logs and metrics, and that if you remove all this, no one will ever notice, because no one is using these logs, no one is using these metrics. Of course, not all the logs, not all the metrics, but when you have data science algorithms that are logging features, for instance, or ingestion platforms that are logging all messages for information, okay, on-prem, maybe it's not an issue, and that's why it was developed like this. But on the cloud, that's the kind of things you pay a lot for. So of course, you can change settings, you can optimize just the things for which you pay, because you'll see that for the same service, you can pay in different ways. Okay, so it doesn't change anything to the service. in the way it works. It just changed the way you pay for it. Like imagine you have data coming through a pipeline service, an ingestion service. You can pay for the throughput, or you can pay for the machines, for the compute that is running. Okay, so nothing changed physically. It's working the same, but you will not pay exactly the same. Ephemeral platforms, optimized queries, scheduled resource scaling. These three things are really classic things for FinOps. So ephemeral platforms, it's whenever you want to use and provision resources when you need them and stop them when you don't. Okay, so at night, during the weekend, no prod environment, this kind of things. Optimized queries, we are in the data department. We have, you have the example of the queries just after? And it's not for the queries, okay. But you'll see that we have interesting, we had like 1,000 euros queries, okay, that run in 2 seconds, and that will cost you a lot because it's scanning a lot, huge amounts of money, terabytes of data, sorry. Egress, just if you can click, the egress part, it's also something that is very tricky on cloud. We had, on this specific example, data scientist he was training an algorithm, deep learning algorithm on-prem. And you know, when you train an algorithm, you will retrain it on the same data set, on the same data epochs, okay, in the training phase. And you want to do it 50 times, for instance, but you don't need to download the terabytes of training data 50 times. You need to download them once, and then to just do on-prem, not locally, but on the server, on the GPU server, what you want to do. If you do it 50 times, it will cost this kind, yeah, you can have this, you can reach this amount of money in just 1 day.
Just to add a point, Victor is very kind because there is another example he wanted to remove, and I caused the 10K bill during the night just because I moved storage from one GCS bucket to another, and it was stored in a cold GCS bucket. So this is another story where during the night you just decide to move, I don't remember exactly, 800 gigabytes of data from one cold storage in GCS into another bucket. And then the next morning you get a call like, I get a bill about 10K this night, what happened? And then you looked at who is responsible and say, oh shit, it's me. So it happens to everyone. So really, and it's very quick.
Yeah, that's part of the, you see, change settings. You can pay for the same things, but in different ways. So you can pay for the storage. If you want to archive things, you will pay cheap, but you need to pay for at least 1 year, for instance. And that's exactly what happened. We just, it was the wrong settings. We removed the data, so we paid for the full year, but the data stayed only 1 day, 10,000 euros. Roadmap, okay, of course, in the optimize, include topics in teams roadmaps. So the idea is really to have people responsible and that to have objectives, at least in the teams, at teams level regarding these different topics. Operate. Okay, so the third steps, enforce FinOps principles. So it's exactly what we described in the previous slides. Now we need to share about all this, about the actions. We have a backlog of actions. We have short-term actions. We also identified things that are more complex to change, but we need to plan them, and we need to make sure that we discuss these topics often. Okay, so we implement some reporting ceremonies. We onboard newcomers on these topics. It's part of the habits, as I said, that they need to have as a developer working in a cloud environment. It's part of the new things that they need to always take into account. We organize the communication, of course, roles, objective in people objectives, roles, channels dedicated to this. And something that we can do is to define budgets per perimeter, because we define our perimeter, we know they are accountable for what they do, and we can define budgets. And the idea is not to be to punish the perimeter, it's just to make sure that we have a way to set a goal and to compare the evolutions. Okay, why did we increase? Why did we decrease? If we decrease, can we apply the actions on other perimeters? If we increase, can we compensate? These kind of things, okay? But it's really important to have a number and a target, I think. Anticipate pricing evolutions, forecast spends and monitoring and monitor trends. Yeah, pricing evolutions. in the last 2 years, we had, at least with Google, a lot of surprises regarding the services and the price. They doubled the price on BigQuery for almost the same service. Recently in Gen AI, so for the LLMs, this is the same. They doubled the price after a few months. So of course, you need to anticipate and understand how you can compensate. And what is what you need to keep, what you need to stop, these kind of things. Design systems taking into account, and that's what, exactly. So onboard newcomers and understand cloud resources. That's the things that they all need to understand when they build a new project or when they do an evolution. Performance, of course, complexity. Let's try to keep the complexity quite low, and the cost. Okay, the cost. If we have something that works almost the same, or if we don't need this kind of performance, but we can run it for a cheaper or more efficient way, we should do it.
Okay, so it's time to move to concrete use cases, because so far we have been talking about the theory, methodology, fair enough. Now we want to put this into practice, and there are a lot of fields in the JCP stack that we discussed, and we have decided to talk about the two main costs in our side, and so what is related to querying, storage, and compute. So basically, in our case, how we deal with BigQuery. And also the streaming and the batch, because we ingest a lot of data and it's important to control the cost in that part. So as Victor said, we use a lot JCP. We have tools like dbt. We are using BigQuery. We are talking about data flow, whatever. So we try to remain generic on what we did here can apply to whatever cloud solution you use. But of course, unfortunately, if we use specific terminology, we apologize, because we try to be generic, but sometimes by habit, we will use our wording. And so first, I'm going to talk about storage and compute and what is related to BigQuery. And a quick reminder about some figures, that just so that you can get insights about what are the figures, the values we use. So for example, as Victor said, we are about 60,000 transformation queries a day. So it means that we are running that many transformations, which will read data, transform them, and put them back in the storage. We have 1 petabyte storage, but basically 3 petabytes transit into the whole flow of processing, because we load the data, we transfer it, we put it back into BigQuery, and we do it again, and again. And we have 1 petabyte storage. It doesn't mean we take all the time all the storage, but we do a lot of computation. And the bill is about 40 key euros per month in the whole BigQuery perimeter between the storage and the compute. So this is an important cost center, and it's a place where we need to apply this FinOps methodology to see if we can take actions to reduce the cost and while keeping the business. So first, how do you use BigQuery? Of course, BigQuery is a storage. It's a columnar storage. It's really like a relational database like PostgreSQL, MySQL, but internally it's based on columnar storage. So generally you access data by columns and you do analytics on it. So it has its importance. We will see it later, but basically we use BigQuery for storage of our data. Using BigQuery is not necessarily very fast. The purpose of BigQuery is to be able to make complex SQL requests. So if you want fast answer, BigQuery is not always the good solution. There is no guarantee about a really fast response time. For that, you have Bigtable, you have Redis, you have other kind of tables. But BigQuery is a long-term, big volume storage. And we use also BigQuery, and on top of it, dbt for the transformation for our computation. You could use, for example, Spark, PySpark, or Pandas to make transformation. In our case, we really use dbt, which trigger BigQuery transformation inside which starts dbt transformation, which transform it into SQL queries that run inside BigQuery. So basically, when we are talking about cost, we are talking about, on one side, storage, the volume we store, but also all the processing we do, because it is an important, more than half of the cost is transforming data. So we load data, for example, from the raw storage coming from various sources, and then we apply transformation. And this transformation, in fact, are BigQuery compute as well. All the SQL queries that load and transform the queries are put back, are just seen as BigQuery cost. In fact, we hide the BigQuery logic with dbt, but what's done behind the scene is BigQuery spawns instances, run the queries, and put it back into BigQuery. It's important to get that in mind that we have two cost sides, the storage and the compute. And the compute is very important because we do a lot of computing, especially in data science. Our data scientists are very happy to test things, to try things, and they load a lot of data, do various queries, and then put them back in BigQuery, and then we see the bill afterwards.
I think what you said about Spark is to really understand what we do with BigQuery. It's a runner. We really use it to distribute the compute. We don't do Spark at all anymore. We use databases like this
in
to
fact,
distribute the compute.
In fact, dbt is the transformation part of an ELT, and instead of using Spark, for example, we use dbt, right? Because it's simpler for analysts or data scientists because they write SQL instead of programming using a programming language. And this is not a talk about dbt, but maybe one day we could do it. So let's start with the storage part. So what did we do? Basically, when you work with data scientists, they want all the data they can. So if they can get petabytes of data, they are happy. But when we see the bill, we are not happy. So we have to find a trade-off between what they want and what we can offer. So the idea is to challenge them of the storage lifetime. So you can say, okay, we keep 1 year, 2 years, 10 years of data, and it's a balance between the cost it will represent and what is really needed. And to simplify your life, you can put, at least in BigQuery and I guess in other storage solution, a data storage lifetime. So you can get data automatically expired after a given amount of time. For example, you can put 1 year, 10 years, so you don't have to set up script to monitor when the data is too old to remove it. And it's really useful because you don't have to take care about it. It's done automatically. I would say we encourage people to reuse data if possible. With BigQuery, we have the capability to define fine-grained access rights. So we can say, for example, you need the production data. Instead of copying it from the production into staging on a dev storage, multiplying by 3 the cost of storage, you can use the data from production as a reference. And then we just put access rights with read-only rights so that you cannot by mistake modify this storage. And I recommend that you use tooling. So in BigQuery, you have automatically lineage, and with dbt also we get lineage. The lineage is a way to see what is the relationships between your different tables. So you can see which tables are the sources, which tables are used, or even which tables are not used at all. So if you can identify easily which table are useless, you can probably do some cleanup as well. Now I'm switching to the second part, optimizing execution. As I said, we have processing, which is a very important cost center. And first, why is it expensive? Because when you run queries in BigQuery, you will get an analyze phase where it will look at all the data it has to process, then execute the query. And you pay in BigQuery for the cost of the process, so the number of resources you use. So the more resources you use, the more you pay. So if we can get less data in the processing, we reduce the processing, and if we reduce the processing, generally it's faster and it costs less because you will pay for less resources. So what have we done? We decide to challenge the needs, again, of the data scientists on my side, and probably on the other teams in your side. But first, we challenge the urgency because, you know, you want that your query run all the time, so it needs always to be fresh. But in fact, we have data analysts who needs the data to make analysis based on yesterday. So you run batch during the night, and you don't need to run again the data, the process. If the process can be done in batch during the night. For some process, for example, for our personalization, we need real time because when the user connects to Veepee, he wants fresh personalization. So we generally run mostly on demand a query to get a really fresh response. So I would suggest you challenge the urgency of the processing. Do you really need real time? Do you really need that you get an answer in a second? Otherwise, just try to put it in a batch to get it delayed. And of course, you challenge the urgency and, as I said, the frequency. You do not need to run the query several times a day. For example, really for analytics, especially, they generally need data from the day before, of the month before. So you do not need to run it several times a day. Really, and it can really change the cost, because let's consider that you have a query that runs every 10 minutes, every 10 minutes. If you can just run it one time a day, you will divide. I did not do the math, but you will reduce the cost significantly. And let's say that you have 10 or 20 queries that way, you really divide significantly the bill without any real change in the business case. And one thing which is very, very important is the volumetry of your queries. As I said, you pay for the analysis which BigQuery triggers. And the more data you analyze, the more you will require resources and the more you will pay. And for that, there are features which exist in almost all data storage, which is partitioning and clustering. So the idea is that you put your data based on key, and then you split them in partitions. So when you query them using this partition key, you will just retrieve a subset of the data. So instead of loading all the data, you will just load a small part of the data. So as I said, less data, less process, less cost. And you can also filter. So do not be shy with filtering with your where clauses when you want really to reduce the number, the volume of the data you will load. So apply the filter early in the process, because if you join two big tables and do the filter afterwards, you will have to load a lot of data, apply then the join, and then do the filter. And if instead of doing that, you filter every entry, you will reduce the number of rows that you will get on every query. And when you do the join, it will be smaller. And again, smaller means less data, less cost. Last but not least, and generally when you do queries, and I do it very often, it's you do a select star from table where. And the fact is that BigQuery is a columnar storage. And really, if you access the exact columns you need, you will probably load much less data in your process. And again, you will pay less because you have not loaded as much data as if you do a select star. Just to show you quickly, this comes from BigQuery. So if you use by default, every data is mixed. So if you use partition, especially, what is interesting is that you can partition by time. Generally, you use day, month, or whatever. And then when you select your data based on these partition keys, for example, you are interested in a month or a day, you will retrieve very few data compared to if you do this and apply a filtering. So the clustering and the partitioning are very useful features that you can take advantage of to reduce the cost of every queries. And as I said, if you run this kind of queries several times a day, you can make big cost reduction. And for me, it's important. In a former company where I worked, we used Oracle, and we did not want to use it as is, and we created an abstraction on top of it just to mimic the features in case we would migrate into another storage solution. And in fact, we created the exact Oracle solutions without the advantage or the benefits of the Oracle solution. And finally, we are stuck to Oracle with a top layer solution. And then if we had to migrate, we would need to rewrite as well this solution. So I would say, know your tool, know your infra, and use it. So if you use Oracle, if you use BigQuery, if you use AWS, just know the tool and use it efficiently instead of creating a wrapper on top of it that will just be stuck to it, in fact, at the end. And for example, I will take the example of dbt because we use it. It comes with this kind of features. So again, the purpose is not to get too much into the detail about dbt, but basically dbt offers for you some features out of the box like defer and clone, which can just restart a part of the process at a given stage. So you don't have to process the whole stage of transformation. Let's say, for example, you have 10 or 20 steps of transformation, and then you want to restart at the 10th or the 12th part. You do not need to process all the 10th first part. You just can start again at the 12th step. So you won't process again for nothing all the previous part. This is really a gain of time, of course, and again, a gain of cost because you won't run all the queries. And I talked about lineage as well already. You have the strategy to write into the database. So dbt is able to manage incremental mode. So it will just make a difference between what's already in the table and what has changed. So it will just insert all the data which has changed and not everything. It will not do a full rewrite. And again, it changes the volume of data you insert in your database. Last but not least, freshness and elementary are features that are provided by dbt. So you can check, you can put healthy checks at the beginning of your process. For example, if your data is corrupted, it would be a pity to have a, I would say, 2 or 12 hours run with hundreds of petabytes processed to discover at the end that your entry data was corrupted or in wrong shape. So with this kind of checks, you can get almost for free, thanks from Veepee, you can get these checks and stop the process if the data is corrupted. And again, you gain time, of course, and you make economy. And on BigQuery side, you have a lot of tooling. Of course, JCP proposes offers for you all a billing tool. You have the lineage, and also you can have job history, which can help you to identify which jobs were very costly or run very frequently. So it helps you to analyze in the FinOps methodology where you can take actions. And we also use intensively resources allocation. In BigQuery, you can pay for pre-allocated resources or use elastic on-demand resources. Elastic on-demand resources are scalable, so you can get some faster analysis, faster answer, but generally it's more expensive. So we use them when we need real-time processing or close to real-time processing, but we try to buy pre-allocated slots and do a kind of ventilation of the job usage. So during the night, we use this slot, these resources for batching. And during the day, we do not run batch, but we move these resources to the dev. So the dev, when they work with data scientists, when they run queries, they use this slot. So we try to optimize the resources allocation in order to control our cost. The idea is that for real time, we use elastic, higher cost. Otherwise, we buy allocated slot and we split the usage depending on the time of the day to use it either for batch or for developers. So using these features, it helped us not to spend 3.5 kilo euros per query and 25 kilo euros a day for deletion. The first one was a 3-second select query on an 800 terabyte for Mixpanel. So Mixpanel is great, but it does a lot of things behind the scene for you. So if you don't take care, it will do a lot of joins, lots of queries, and it can really select a lot of data. And for example, the select star on 800 terabyte costed that much.
Mixpanel, it's eventing data, tracking data. Okay, it's like when you visit, click, scroll on the website, we track everything. So you can imagine the volume is quite huge. We have 3 million visitors, unique visitors a day. So it generates a lot of data.
And the second one was delete calls running all the time and not using the partition usage. And finally, instead of just selecting the right part, the scan was done on all the tables. So again, and it was run several times a day. And at the end, when you see the cost in the day, it can be very expensive. So you see, this is not, I mean, it's not that complicated. If you apply what Victor said, if you apply monitoring, you identify where to action, you can really gain a cost. It does not mean that it's cheap using the cloud, but if you do not pay attention, you can have extra costs that are useless, because it's better to use 25 kilo euros to do data science, artificial intelligence with Gemini instead of just paying for logs or for deletes that are not very well designed. And now we will switch to the data pipeline. So I switch back the floor to you, Victor.
All right, we'll try to be fast. I think we are a bit longer than expected. All right, so well, it's very specific what we are trying to explain, but again, I'll try to give the main ideas and things that can be reused, okay, in your own companies. First, streaming batch. Well, I think it's quite obvious. We have data coming in real time, and we have data that from time to time we pull out of different systems. So of course on a scheduled basis. So batch ingestion. Okay. The real time, it's interesting because we are doing some streaming analytics for encryption. So we are dealing with user data, usually, sometimes sensitive data, employees data, and we need to encrypt them prior to put them and load them in the database for the analyst. Okay. We add some fields, some technical fields, and we validate the structure of the messages of the entities. Okay. So maybe let's move to what we do for the streaming part, which is most of the data we ingest. So as I said earlier, 300 million messages a day approximately. So what we have in the data department is a homemade ingestion platform. The idea is to provide a service for the product teams in Veepee Tech to expose their data entity. Okay, so they push the messages, the data entities, the rows and the tables when they want, either in real time if it's connected to their systems or on a schedule basis. But after the push, everything is always running and is always processed and ingested in the database. Okay. On this graph, you see we have internal sources. Okay, we are only dealing with internal data. Not only, but almost only. So we connect to internal sources, and sometimes we connect to SQL Server, Kafka, tools that are provided by the other teams, and sometimes we provide ourselves specific endpoints. So build around the concept of data contracts. Okay, this platform is built around this concept. The idea that we have the business that wants something for to enrich data entities, to do some analysis, like for instance, the list of campaigns that we have on the homepage. The business wants to know what is the content of the homepage at a specific moment in time. And we have the product team, the front teams that are creating the homepage and updating the homepage. So they push and they expose this kind of data, for instance. So we provide a tool that will generate all the resources dynamically. And it's a contract based on a contract. It's just a list of fields and some meta entity ID. And when they push on our side, we do all these things. So we check the schema. We have replay capabilities. We can handle the evolution of versions if they want to add, change types, delete fields, and we can of course do encryptions. Let's move. Yeah. Okay. So of course, all this to have the quality. At the first steps, so the idea is really to reduce the incident that we can have in the processing, in the transformation phase, and to really put also in charge the product, the responsibility on the product side, and try to have them owner of their own data entities. Okay, so technically on this, on the previous chart, we had the Agat. Agat is just the name of the internal solution, sorry, the ingestion platform. So how it works, we have, for instance, for the gRPC solution, our data contracts are generating for each data entity a specific endpoint on which you can push protobuf messages, so that are compliant with the structure of what we expect in the data contract. They are pushing in the endpoint. The endpoint is putting the data in a dedicated pub/sub. It's just a bus, message bus, and then we have pipelines. So here is the compute, the data flow, what I explained earlier. It's this solution that will run and that will provision machines to always process the message in real time. And then it's writing the data in dead letter tables or raw data tables or backup, because we have, you see, two pipelines that are handling the same ingestion. Okay, so there is something interesting here is the fact that we are providing bus. Anyone can technically subscribe to this, and it's like the beginning of what we call the event-driven architecture. Okay, so if they want to use our solution to expose data entities for other use cases and reporting, they could. And this part is always live. Okay, it's not streaming analytics. This part is just okay. They have message bus, it's live. We can have subscribers on this buses. But on this part, that's where we are losing a lot of money. Of course, we are reusing, maybe you can go to the, no, not this one, sorry. Okay, let's say. We are reusing, you see the pipelines with different sources and different destination, but it's not enough. Here we have machines that are running all the time for data that we might not need in real time. And 80%, 90% of the time, we don't need the data in real time because behind the scene, people that are using this raw data, so the data analysts, the governance team, the data science teams, data engineers, they just run scheduled jobs every hour, every 15 minutes maybe, but that's it. So as I said, we are spending a lot on this part. When we started with this architecture 6 years ago, the idea, the forecast was that we would spend, with the different synergies, with the increasing of the volume, we would spend 5,000 euros a month for the ingestion only, not for the processing. So what I just showed. And last year we were spending 15,000 euros a month on the ingestion part. Why? You spoiled it. Why? Because yeah, we had a huge diversity of pipelines. We were redoing in different teams the same ingestion, not the same, but using different solutions for the same purpose, which is just sourcing Kafka topics, for instance. So we were duplicating also the resource needed to ingest that in real time. And of course, we had more volumes than expected. The scope increased a lot. But lately, we decreased a lot and we went back to what was the original forecast. So how did we do? Nothing impossible. We just started with the inform phase. Okay, we need to know where we are losing money, how much this part is what are the costs on the Kafka ingestion, what are the costs on the backup compared to the pipeline that is doing the encryption, for instance. You want to say something, Pascal? No. So we added labels and tried to access the data day per day. Why streaming? We cutted duplicated streams. We leveraged direct database connection and pay for throughput. So it's what I explained at the beginning, the fact that you can just change the way you pay for exactly the same thing. So you can, for instance, in GCP, connect directly a PubSub bus to BigQuery, as you can connect a Kafka topic to a ClickHouse, for instance, and you will just pay for the throughput and not for the resource behind, for the compute behind. Error management, we had a lot of the way the pipelines were structured, the pipelines were failing and sometimes stuck in training and scaling at the maximum for 2 days because it was during the weekend. So it was costing a lot, the fact that the pipelines were not running correctly. So we worked also on this part, trying to use, for instance, vertical auto-scaling to avoid the memory issue, the out-of-memory issue. This kind of things that you can try. You just change the settings, the way you scale your resources for your streaming pipelines, and it will solve and save a lot of money. Scaling, as I said, and synergies, of course, stopping doing exactly different things for the same use case, for the same purpose, trying to have one common place to ingest data and to connect with the rest of the world.
Okay, it's time to conclude and we are running a bit out of time. I apologize, Victor, because I took longer than planned. So it's time to conclude. So to summarize, we really recommend you follow a FinOps methodology. Use monitoring, measure solution. You can get them from scratch directly in your probably cloud solution. Choose really where to act, because there are places where it will cost money, but it's for business. But there are places where you just waste money. The log example is really probably the most significant. You generate lots of logs for no use on a lot of cost. And we can say it works because we managed to restore the trust. And so it's still the honeymoon, and we did not break up, as I said this morning. So we are still happy with the GCP stack, and we must be careful because it's a never-ending story. You create features, it has again a cost, and you have to keep this loop, monitor, control, act again and again and again. But it can work, but you must be careful because the cost can really be quickly very high.
I think that one of the key elements is really the trust, as you said. The trust is here because we show that we are in control. It's not about really how much it costs at the end, of course. So we decreased by 40%, I think, the spend, the monthly spend after 1 year of different actions. But the thing is that we are in control with our costs, and we are confident with the evolutions that are coming from the cloud provider. And we anticipate a lot, and we always have plans to cover the increase or to cover changes. Okay, and that's really the value of this, that you show that you are in control with the tools that you have, and you are just not suffering from 10,000 euros, 25,000 euros a bill for 3-second queries or these kind of things. Okay.
Thank you very much. We will leave the floor so that Olivier can set up his infrastructure and his setup. So, and if you have questions, we stay in front of the desk and you can ask questions. Thank you very much.
Thank you.